In this video, I'm going to be walking you through how to build an arbitrage trading strategy which leverages pairs trading to buy and short two stocks to profit from unexpected price deviations between the two stocks. Stay until the end to see the full results on a 5-year backtest. As always, all of the code and data will be linked below in my GitHub. This video, like all of my videos, are for your education only. Please do not use this in a live trading environment. And with that, let's get into the video. So I'm going to start by importing the libraries we're going to be using for this video. The first is pandas, the second is numpy, the third is seaborn, which we'll be using in combination with matplotlib. And then the final is the backtesting.py library, and from this we're going to be importing backtest and strategy. All of these will be linked below for the documentation if you want to read on them further. So I'm going to run that. Now, the two stocks we're going to be using in this video are Coca-Cola and Pepsi. Now, the reason we're going to be using these two stocks is because the companies are very similar. They're affected by very similar external market forces, and they're a great candidate to build a pairs trading strategy from. So we're going to begin by we're going to begin by loading in our data for Coca-Cola. So I'm going to read in as a CSV this Coca-Cola from 2005 to 2025, and I'm going to rename the close price to KO close. So KO is the ticker symbol of Coca-Cola, and the reason why I'm going to be doing that renaming is because when we merge this with the Pepsi data, we want to have different column names. So I'm going to run that and load that in, and we can see we've got our data here. Now the next step is to load in the Pepsi data. So let's run that, and we can see we've got our data for Pepsi as well, and we've changed the close price to pep_close. The next step is to combine these two datasets together. So I'm going to create a variable called data_comb, which is short for combination. And from the Coca-Cola data, we're going to select date and the Coca-Cola price, the close price. The reason we're selecting date is because we're going to merge on the date column. So we're going to select the same two columns from the Pepsi data. And we're going to drop NA, and the axis is going to be 0. So that means we're going to drop any rows that are missing, just in case there are certain dates where, say, Pepsi was trading but Coca-Cola wasn't. We're going to run that, and we can see now we've got our combined data. Now what would be nice is to plot these two stocks on a graph and see how the prices move with each other. Now unfortunately the prices are quite different from one stock to the other, so what we're going to have to do in order to plot these is to scale the prices for each individual stock. So to do that, we're going to apply something called min-max scaling. So I've created a function here called min-max scale, and the input to this is a series, and what it's going to do is it's going to convert the close prices from values 0 to 1, with 0 being the lowest close price and 1 being the highest. Now if we do this for both close prices, we can then plot them on a graph under a common axis. So now what I'm going to do is I'm going to create two new columns. So I'm going to create a scaled close column for Coca-Cola and a scaled close column for Pepsi. And I'm going to apply this min-max scale function, and the input is going to be the close prices for each of those stocks. And I'm going to run that, and we can see that we've got our scaled close prices for each of those stocks, so we can nicely plot them against each other. So I'm going to create two line graphs using seaborn. So if I run this, we can see what this looks like on a graph. So what we can see is that when one stock goes up, the other tends to go up as well. And when one goes down, the other tends to go down. But not always, right? This doesn't always happen. And that is where there's an opportunity to apply pairs trading to make some money. So for example, let's say at this point, let's take this point here, right? We see that Pepsi has crossed above Coca-Cola here, and it's gone quite high, right? So if we were to short Pepsi but long Coca-Cola, we might actually lose some money if it went, say down here from Coca-Cola. But the profits we make from Pepsi are going to be a lot greater than the losses we incur from Coca-Cola, which would make this a profitable pairs trade. So it's about trading two stocks at the same time, longing one and shorting the other, and making money from the difference. Even if you lose on one of them, the idea is that the profits on the other will outweigh the losses on the other stock. And that's exactly what we're going to be testing out here. So what we need to do is we need to calculate the spread of these two stocks in order to determine when we should short one and long the other, and also at what point we should do that. At what point should we short one stock and long the other? The spread has to be above a certain threshold. So that threshold specifically we're going to be using is called the Z-score or Z-score, and when this score is above a certain threshold, we can enter into a pairs trade. So the input to this is going to be two series. So this is going to be the close price of Pepsi and the close price of Coca-Cola. We're going to create something called the hedge ratio. Now, the hedge ratio is a ratio that enables us to buy a certain amount of one stock that another stock or the other stock is not going to have that same price. If we were to buy, say, for example, 1 unit of Coca-Cola and 1 unit of Pepsi, it would cost us over double to buy 1 unit of Pepsi versus Coca-Cola. So we would need to buy or short twice as many stocks of Coca-Cola, in this case against Pepsi. So this is where the hedge ratio comes in. So after calculating that, we can then calculate the spread, which is the first series, and then from that we subtract the hedge ratio multiplied by the second series. And then once we've calculated the spread, we can then calculate the z-score of the spreads. And then we're going to return that right here. Now, the next step is to assign the spread and the z-score to columns to this data_comb data frame. So I'm going to call this calculate spread z-score, and then the input's going to be the close of Coca-Cola and the close of Pepsi. And I'm going to run that, and we can now see that we've got our spread and the z-score here. So what I'm going to do is I'm actually going to plot the spread just to show you what that looks like. So we can see that this is the spread over time, and what we're doing with pairs trading is we're essentially trading the spread. We're either going to long the spread or we're going to short the spread. And it's essentially a mean reversion strategy. Now, when do we know when to enter into the trade? Well, this is where the z-score comes along. So I'm going to show you what this looks like if we plot the z-score. Now, you'll notice if we ignore the y-axes, it looks exactly the same. I've added these lines here just to show you when we would perhaps enter into a trade. But if we're just looking at the blue line, it's exactly the same. The only difference is that we've changed the scale of the y-axes to be this z-score. So basically what we're saying is, if it's above 1, we're saying if the spread is at least 1 standard deviation away from the mean, then we want to short that spread. And if it's below 1 standard deviation from the mean, we want to long that spread. So you could think, for example, here, we might short the spread, and then perhaps we have some take profits, and then we might want to long the spread. We might short the spread again here, and then we might want to long the spread along here. And the idea is that this spread reverts to a mean. Now, there are more advanced statistical tests you can do to check whether the spread is mean reverting. We're not going to do that for this video. I just wanted to give a basic overview of how this works, but absolutely look into mean reversion statistical tests and also co-integration as well. That's another important statistical test to make sure that there is a historical statistical relationships between the two stocks you've picked. For this video, I'm just going to keep it simple. So I'm going to create a new variable now, a new data frame called backtest data. And what I'm going to do is I'm going to rename the column spread to close. And that is just because the backtesting library expects a data frame of stock price data. Now, because we're actually combining 2 stock prices, we're going to have to rename that to be close and just pretend that the close price or pretend the spread is the close price. So I'm going to run that, and we can see that this is the backtesting data that we're going to be using. Now, the backtesting library also needs some other columns as well, so we need to provide an open, high, and low, and I'm just going to set this to the close. Now, the library's not going to use this, which is fine. We just have to provide it, otherwise it will throw an error. Now, the next step is to build our strategy. So I've created this class pairs trading strategy, and I've defined our take profit arbitrarily as 10% and our stop loss as 5%. Now, I've defined these 2 other variables here. So this is min z-score long. So what is the minimum z-score to actually open a long position or to long the spread? So we saw before, I drew these lines here, right? So if it's -1, then we would long at this point here when it's crossed over this line. And then we would short if it's above 1. So we can see that we've got these variables here. So then if we look into the next function of the strategy, so we take our current spread, which, as we know, we're just calling the close price for this. We take our current z-score, and then we take our previous z-score, and this is to allow us to identify whether there's been a crossover. So for a long position, i.e. we're longing the spread, we're saying if the previous z-score is less than the minimum z-score to long the position, but the current is greater, that means it's crossed through that -1 line, and we want to open into a long position on this spread, right? So we're going to be shorting one stock and longing the other in practice, right? Obviously, for backtesting, we're not doing that directly. And then for shorting, it's the exact opposite. So we're saying if the previous z-score is greater than the max z-score to short, but the current is less than, then we know that it's crossed down below this red line and we want to enter into a short position on that spread. Now, finally, we have the take profit defined as the variables up here for the longing the spread and shorting the spread as well. And what we're going to do is we're going to optimize this particular strategy. Now, earlier on, when I wrote this code, I did an optimization for 2,000 iterations of different variables that we could plug into the take profit, stop loss, and these two variables here. And I found some values that work quite well. So I'm going to save you the time and I'm going to show you those in a second. Before I do that, I'm just going to define the strategy. So we're going to say BT equals backtest. We're going to input our backtesting data. The strategy is, of course, our pairs trade strat. We're going to load it up with 100,000 in cash, and then the commission is going to be 0.2%, and then we're going to use 0.2 margin, 1 to 5, and then we're going to set exclusive orders to true and hedging to be false. That's because for this strategy, we don't want to open multiple positions at the same time, because it's pairs trading, we're going to open one at a time, so that'll be one long and one short. And the same goes for hedging. I'm going to run that. Now, in order to optimize this, and I'm not going to do this because I've already done this, but if you wanted to optimize this, these are the values which I use to do the optimization for each of the variables, and I use 2,000 max tries. So I'm just going to comment that out for me. But if you wanted to optimize it, then feel free to do that and change some values around. In terms of the best parameters that I found, they were these parameters here. So we have a min z-score long of minus 0.75. The max z-score short is 0.25. Then we have a 5% take profit and a stop loss of 0.25%. And what I'm going to do is I'm going to run the backtest on these best params, and we can see what the results look like. My mistake. So we can see that the return is 1,182%. Now our buy and hold return would be minus 65%. That doesn't apply really for this because it's a pairs trading strategy, but our return would be extremely high, and that's even with a commission on there as well, right? Now you might want to double up this commission because we're pairs trading, right? So there's 2 commissions to pay. So if we set that to 0.4%, we still have a very nice return of 855%. Now of course you want to test this out on some unseen data. I haven't done that here because I just wanted to show you how to build it, but absolutely test this out on unseen data. We have a pretty good SQN for just an initial strategy. Obviously, you want to be looking at least 2 for a really high quality strategy, but 1.78 is a really good start. We can see that our win rate is 54.83%. Now the win rate isn't actually that important. Obviously, your risk to reward ratio is very important. Now, if we look at our take profit, we have a take profit of 5% and a stop loss of 0.25%. So we have a nice risk to reward ratio of 1 to 2 here. So with all that, you can absolutely do more research on this, optimize it, improve it further, make it a lot better. As I said before at the start of the video, all the code will be in the description below in the GitHub, so feel free to take it and make it your own, do whatever you want to it. But this is just an introduction to what could be done. So that's the end of this video. If you did enjoy, please subscribe and like the video, and I'll see you in the next one.